Hello everyone. Okay, what I'm going to do in today's tutorial is to actually connect my local network or a network segment to another network. You could substitute it for modem or just another network. Just simply shows you how to connect your network to the internet. We're not going to be using a real internet or a real modem right now. We're just going to be using another router which will act as our modem. Okay, first things first, I'm bringing my PCs out. Then I'm going to go to on my router, bring this router. This router will be for our local network. Then this one for our ISP. Then this guy, a switch as usual. Then the next thing we're going to do is connect our PCs to the switch, then switch to the router, then connect these guys together. Okay, without wasting much time, fast Ethernet port to start from 2, connect this one to 3, then we connect this one to 4. Okay, connect this one directly to connect one fastnet 1 0/1 to our router's fast Ethernet 0/0. Please do take note of this connection here. We're connecting fast Ethernet 1 of the switch or 0/1 of the switch to our router's fast Ethernet port 0/0, because the second fast Ethernet port is what we're going to be using to connect to this router. So I just want you to remember so that I won't have to come back to it again. So let's just connect it directly now. Okay, fast Ethernet 0/1, as you can see here, to fast Ethernet 0/0 on the other router, which is going to be acting as our modem. Okay, first things first, this is a network, this is a local network. And the next thing we're going to be doing, so for this network now, we want to currently this particular line or this port for this router, all the ports on the routers are actually shut down now. So we have to go to the routers, each router, and configure them. But first things first, we're going to be configuring just this router for now before we move to the next one. In this router, what do? We go to our CLI. Let's maximize this. Type N or no, and enable. I'm not going to be using shortcut keys, or I'm going to be writing everything in full for those of you that don't know how to use the CLI of a router. Okay, we've entered that. So we go to our configure terminal. So config, let's just config T or configure terminal. So from here now we can configure our ports, we can configure our gateways, DHCPs, and anything else you want to configure. So let's see. First things first, let's go to the fast Ethernet port on this router. That's this particular place is where we want to go, where we want to configure for now. So we go there, which is our fast Ethernet 0/0, whereby going to interface interface fast Ethernet 0/0, enter. As you can see here, we're already in that interface. For those of you that don't really know how to use the CLI, once again I have to reiterate. So now that we're there, let's go to no shut or no shutdown, enter. Okay, as you can see, look at it here, it's green, it's coming up. So let's go there, give it an IP address. This is the importance of this cannot be overly emphasized. So we must give every port on our router must have an IP address. Every port on our router must have an IP address. That's for routing, to enable routing. If not, it won't route, it won't just go anywhere. So IP address, let's use 192.168.10.1 That's our IP, the IP for that particular fast Ethernet port. Then next thing we add is our network mask, 255.255.255.0, which indicates that our network or IP address is in the class C subnet. Class C subnet 255.255.255.0. If it was in a class A subnet, it would be 255.0 or .0.0.0. Okay, now that we know that, let's continue. Now we've given it an IP address. That port is configured. Exit. One more thing for you to know, this port is what we'll be using as our default gateway for that network. Okay, this port, which is 192.168.10.1, will be the default gateway for this network. I hope you understand. But whatever it is you don't understand, you can let me know in the comment section, alright? So that I have to explain it in other videos. But I'm now assuming that everyone knows what the default gateway is, what ports are, and all of that. So let's see the next thing to do now. Okay. Now that we've configured this port, we've given it an IP address. What we want to do, okay, we would like to configure a DHCP on this router. It's necessary, very necessary, especially if you're working with a network that has a lot of systems. You won't have to, or you won't. It will be tiring to have to go to each system and give it an IP address. It doesn't work. It's not feasible. So let's go to enable again. Then we'll go to our configure terminal. You could use conf or config T as a shortcut. It does the same thing, because the CLI of both router and switch, Cisco's router and switch, actually give room for shortcuts. So let's go to, since we are on this now, in order to create a DHCP, the first thing you should do, write IP DHCP. One more thing, if you don't understand, if you don't know what to do next, just give it space, question mark. You'll see it here, excluded address. Excluded address actually prevents a certain range of IP addresses from being assigned to devices. So you could just give a certain range, then maybe by yourself. Maybe if you want to give it to a printer, an address to a printer or a server, static address, actually, you could give an excluded address range. Then from that range, pick these IPs that you want to use personally for yourself. But right now, it's not necessary. Let's just keep that. IP, what we want to use is pool. As you can see here, configure DHCP address pool. Then the next thing, let's put a question mark again, word or pool name. Let's give this one net. Let's just say let's call it local. You could call it anything, or main if you like. Main. Let's use main. Okay, now that we've given it a name and we are now in the DHCP, the next thing to do is to give it a network. It must have a network. Yep. Or you could type for shortcuts. If you type net, you could just press the tab key. It also completes it for you in Cisco command line interface. So let's see this now. We have our network. So what do we do? 192.168.10, which is actually the network, that's the default router, or that port that we configured, the IP of this port here. This network, this IP's network, is what we'll be using. .0 actually indicates a network. If I had added a number here, maybe like 10 or 20, that would be an IP address of a device. But this is what we want, a network. Then 255.255.255.0 network mask. That does it, network, IP address, and okay, we've done that. What we want to do next, for every DHCP pool, it needs a default router or default gateway. 192.168.10.1. This IP address of that line, or that port if you like, is our default router. You don't need to actually add network mask here because it already knows it's on the same network. So we've added our network, we've added the default router for that network. So next thing to do is to exit, and I'm going to prove that this works simply by going to each system. All these systems are supposed to be on the network because their default routers are going to be that line, but now it's static. I'd have to configure it manually. Why should I bother when I could just go to DHCP? Then it gets its IP from this line, from this default router. It gets its IP from there, right? I hope I'm making sense. Just in case you don't understand anything I've said, I will explain. You just have to okay, this one has gotten his own IP address. You just have to drop a comment for me and tell me whatever it is you don't understand. Okay, let's see. Okay, yep, see, this is the network part. This is the network portion, 192.168.10.4.4. This number here for figure 4 at the end is the host portion. That is not part of this course. So if you don't understand anything concerning networking, you can just drop a comment in the comment section, and when I read, I'll try to explain in future videos. Okay, let's go. And now what we want to do is configure this port. This one, yeah, okay, we want to configure this port and this port. Note, for these ports to communicate with each other, regardless of whether a line, since this line is connected, if this port is on a different network, or has a different network address, or is on a different network, I think that's the best way to put it, and this port is on a different network, even if they are connected directly together, they won't communicate. I hope we understand that. So all we want to do is to go to this router, then configure this port, then come back to this router, configure this port. I have to take it step by step. I think I'm making a mistake. Okay, yeah, I'm not making a mistake. Okay, so we go to that. The next interface will be interface 0/1, I guess, of that router. So interface space fast Ethernet 0/1, no shutdown. Okay, let's go and see if it will be working. Okay, this is it, but it's not working yet because this guy too is still not shut down. Regardless, let's just give it an IP address. This guy is shut down, sorry. Let's just give it an IP address. Then we'll go to the next router and configure it. IP, let's give it an IP address of a class A network. IP address 10.0.0.1. You can choose any other network you like, but let's just give it this one. And mind you, if you're using 192.168, you could be on the same subnet and it will cause problems for you here. 255.255. I'm sorry, 255.0.0.0 class A address and the class A subnet mask. Okay, now that it's connected, so far the most part of this router is already done. So we'll have to come here and to this CLI of the other router. It's just connected. Okay, trying to go as fast as I can and still trying to make sure you understand, so forgive me if you think I'm taking too much time. Okay, figure T. Okay, so this one, it's on the interface, it's on fast Ethernet 0, int fa 0/0, that's the port it's connected to. IP address address, no, not DHCP, IP address 10 10.0.0.2. The other address was .1, so this one has to be .2, and like I said before, they have to be on the same network. 0.0.0. Have I done a no shot? No, no shutdown to bring it up. As you can see, it's green. Both lines or both ports are administratively up at the moment. Okay, so let's see if we can ping it, right? To be sure that it's working. Control Z, then ping 192.168 dot, sorry, I'm pinging the other network 10.0.0.1. Let's ping this guy and see. You should work. Yeah, as you can see, sorry, success rate is 80%. Why you should be 100? Let's do it again. Success rate is 100%, 5/5. So this guy can ping this guy. Definitely this guy can also ping this guy, since they can ping each other. I don't want to waste time on that. But this guy, we want to see if this guy can ping this guy. That's 192.168.10.1. Ping 192.168.10.1. Right? 192.168.10.1. Let's just cut the long story short. It won't work. Success rate is 0%. It's not even going. The reason is because this guy can ping this guy, but on its routing table, there's no way it can get to this guy, and there's no way this guy can get to this guy. So we have to configure a route here on this router to get to this guy, and another route here for this guy to get back. If this guy can get here, but there's no way for the packet here to come back, it still won't work. So what we're going to do, like when you're configuring connecting to an ISP server or modem, what you do mostly is exit. Okay, what you do mostly is use a gateway of last resort. Yes. Okay, since we've been able to connect this port, or sorry, give an IP to this port, an IP to this port, and we're now certain that both ports can ping each other, meaning they can transfer packets between themselves. But what we want actually is to be able to use this network or devices on this network to connect or to be able to reach this port here. Normally it wouldn't get there because they are on different networks. We have to actually create a routing. So this is where we come. I actually done something earlier, but I'll have to clean it or erase it. Sorry about that. So what we're going to do right now is we could actually create a static route to that port if we knew the network we are going to reach. So static route would be something like this: IP route. The network we want to get to, let's just use 0.0.0.0.0. The network we want to get to, its subnet mask, and then the next hop address. That's the next address outside the router that is going to transfer packets through to the network we are going to. 0.0.2. But let me explain what I did here. Normally, if we were going to use a static route, like I said, we have to these four sets of zeros would be the network we are heading to, we want to get to. Then this next set of zeros will be the network mask. But right now we don't know the network mask. Let's say we were trying to ping or reach Google, and we don't know the IP address of Google's network address, or we're trying to reach Facebook and we don't know its network address, or any other site you can think of, we don't know its network address. So we don't have to keep going out and searching for network address and putting it on our routing table. It will be quite cumbersome and stressful. So what we will do normally, or what best practice actually, or should I say only practice, trying to reach out, is to create an IP gate, a gateway of last resort, which this is a way to create a gateway of last resort. IP route 0.0.0.0, then 0.0.0. This 0.0.0 first represents its network, then a mask, but we don't know what they are, so we just put them as 0. These are called wildcard bits. Then this 10.0.0.2 is the next hop address. Let's create it first and I'll explain what it means. Let's say this system was trying to ping Google, and Google is not on the Google's network is not on the routing table of this router. So instead of stressing this router or dropping the packet, what we do, or what this router does, is send that packet to the next hop address. And the next hop address is the next port which is going to use to get to that network that it doesn't know. And the next hop address is this guy here. This is what we used as our next hop address. If this was a modem, if we send the next hop address here, they will be able to connect directly to the internet. So it will work, meaning that we'll be able to reach the internet. Well, now let's see. Once we're sending it now, or let's say we've sent it, the next hop address now, supposedly we should feel we've done it right. We should be able to reach the internet, and data should be able to flow between routers. Okay, now that we've connected, we've been able to give our router here a gateway of last resort. It will be able to send packets from this network to this network. Certainly it will do that, but this packets won't come back because we don't have a static route here. We don't even have IP routing on this router, so the packet will still not be successfully sent. I really didn't want to waste so much time on this video, but clearly I think I have to. The more I try to explain in haste, the more I think I'm confusing everybody. So what we're going to do now is okay, we've created our IP route. So let's just create another one here, another routing here, without wasting much of your time. Enable config T. But if this was a modem, you wouldn't have to do all of this. You wouldn't configure the modem like what I'm doing now. I'm just doing it just in case you need to connect to or configure other networks, like two networks to communicate with each other. You could use static route or gateway of last resort. Okay, on this now, let's use static route just to explain to you what I meant earlier. So now IP route. What network do we want to get to? 192.168.10.0. Sorry, I did 10.10 there. 10.0. What is its network mask? 255.255.255.0, because it's a class C network address. Okay, 255.255.0. Okay, what the next now? Okay, let's confirm. It will be the next hop address. Next hop address, which should be 10.0.0.1. Now, okay, let's do exit. Let me just show you something. Let's see if they can now ping each other. Ping 192.168.10.1. Yep, it was successful. Let's ping one of these systems, 10.2. 192.168.10. Oh, sorry, I didn't use ping. Ping 192.168.10.2. I think we have a 2. Yes, 80% was actually successful. We tried again. Yep, it's successful. See what I'm trying to get at? I'm sorry it's taking this long. It wasn't supposed to take this long. So we configure the static route here, which in turn sends packets here, and this guy is somehow on its routing table, or because of its routing, is able to find its way back to this one using the the gateway of last resort. This one is using gateway of this particular router is using gateway of last resort to get to this router. This router is using static route to get to this router. When configuring routes, as is here, IP route incoming, IP route 192.168.10.0, then the network mask, then the next hop address. We have come to the end of this tutorial. I know it's been a very long one, and this was not my intention anyways, and I'm not done. But for time's sake, I think I have to stop here. If we wanted to connect to the internet, and let's say we replace this guy with a modem, there will be no need for us to configure an IP routing on the modem. So all we'll need is this interface here, the IP of this interface for gateway of last resort. So all we need from this interface will be the IP of this interface for the configuration of the gateway of last resort, and it will be our next hop address. And after that, we'll have to NAT this interface to NAT this interface inside, NAT this interface outside. Actually, this will be NAT overloading. So I don't know if anyone is interested in NAT, or if you know NAT already, no problem. But if you don't know NAT, if you need to connect to the internet, all you need to do, the last things you need to do is to NAT this interface to this interface. So if you want to know how that's done, leave a comment for me in the comment section, and I'll see what I can do. If this video has in any way helped you, please do drop a thumbs up, leave a reaction. Right, that will be very, very helpful. Alright, thank you for watching.